Hello, Fruitport High School students. Welcome to our next lesson. Today's lesson, I want to talk to you about different ways that we can separate mixtures in the lab. And so I'm proud I got my blue and white night recording blue and white colors going today as Spirit Week's going on. And so you'll be watching this video on Friday or on Monday. And again, I think it'd be a good idea for you to take some notes. I got some vocabulary words for you. And if we ever do an open note quiz, that way you have some notes open for you. Okay. So the biggest thing I want you to take advantage of this or take away from is when we separate mixtures back into pure substances, we're going to take advantage of different physical properties, right? So the mixture is made of substances and there's some physical property we can exploit, right? Maybe if we had a mixture of metals, we could use a magnet if one of them's magnetic or not. Or maybe it's a color. For instance, I sometimes forget to tell people when I order a salad at a restaurant, no tomatoes, please. And so I got this mixture called a salad. I don't want to eat the tomatoes. So I physically just pick out all the red things because the red things are tomatoes. So I just use color and I just use, a fork. Sometimes the things are more like science sounding, and you'll see those in our lesson. Another one is solubility, and you should write this down. Solubility is the ability for something to dissolve in water or another substance. Like sand does not dissolve in water, but sugar does dissolve in water. So sometimes we can take advantage of that some things dissolve in water, some things don't. And this last one is BP. That's short for boiling point. Sometimes if substances are mixed together and they have different boiling points, we can separate them. Okay. So take a look at some of these next slides coming up. Okay. So the first vocab word I want you to realize is filtration. So filtration I'll read it to you. It's a technique where we separate a mixture based on the state of matter or the size or some other properties by passing the mixture sample through a barrier that will collect part of the mixture. So if you have a mixture of solid and liquids and you pour it through a strainer in the kitchen, like you're cooking mac and cheese and you have solid macaroni and liquid water, the strainer is a filter, okay? And you can separate it by state of matter. Some filters work by letting small things through and collecting big things, like a screen on the bottom of a box that an archaeologist is, trying to dig up dirt from an old buried city. And they kind of sift this box back and forth. And the sand comes through, but maybe a coin or a bone or a piece of pottery gets caught by the screen, okay? Water filters, like a Brita filter works the same way. And so there's a lot of different filters out there, like Brita filters might collect things based on charge and stuff like that. So filtration, I think you got the idea. Let me give you one more example. I remember Bear Grylls using his own t-shirt to filter out muddy water, the mud out of the muddy water so he could drink the water. Maybe you guys know who Bear Grylls is, okay? So here's a picture of a filter in a lab, and they got this fancy filter paper. They're going to pour something through it, and the paper will catch the solid. The liquid will drop through. You'll get to experience that in yourself. All right, another vocab word is chromatography. So this is a technique where we separate a mixture by allowing a liquid sample to slowly flow up. Oh, I spelled that wrong. That's supposed to say flow up a porous sheet of paper, but it's slowly flow up. Sorry about the typo there. And so we take advantage of size, mass, or charge in this situation, depending on the type of chromatography. They use this with DNA. I'm going to show you an example where we do this with colored markers. Is a green marker really made of green, like ink, or famously blue and yellow make green? Maybe a green marker is made of blue ink and yellow ink that made green ink, right? So chromatography would allow this to happen. And you may have done this in middle school. This will make more sense when you see a picture of it. And here's the picture right here. So here they put different samples of some kind of dye or something on a little drop on a piece of paper. And the little tip is touching the water or whatever solvent they use. And as it soaks up the paper, it can carry the color with it, stretching out a mixture like maybe a green sample would stretch out into blue and yellow. Okay. All right, another one is distillation. Now, this is my personal favorite, so you can guarantee this is going to show up on the test. But this is a technique to separate a mixture of liquids based on different boiling points. And there's this complex glass system, and where you can boil something and it recollects it. You may have seen this in like moonshiner shows. They use a distillery process to make the alcohol. But in the science lab, we use it all the time. I use this a lot in college, in my college lab days. And sometimes if we want to separate salt and water, like into pure salt and pure water, we can take advantage of solubility. Now, let's say you took salt water and you just boiled the water. All the water turns into steam and kind of escapes, right? And you would get the salt, but the water has been lost to the vapor in the room. Now, let's say you wanted to have salt water and you wanted to separate salt and water, but make sure you collect the water. The distillation apparatus will let that happen. So this will make more sense when you see a visual, which is going to be in our second video in just a few minutes. Okay. All right, here is a picture of distillation, like in a cartoonish version of a moonshiner kind of sample. And then here's how the distillation works. Well, I can explain it for you here without the video. But if you put a sample of like salt water here and you heat it up, the salt stays behind, but the water turns into steam and travels through this tube.